All right, dude, we are live. What's up, guys? This is Dan Keys, and holy shit, dude, I found an ESP32 Rust gold mine. So, ever since I got into doing ESP32 Rust stuff, it's always been like the information has been kind of spread out all over the place, and you kind of have to go searching for the information. You have to pull bits of information from different sources. At least that's the way it's been for me. They did have a no STD Rust training book, but that book is also it's great up to the point of maybe installing all the tools and getting a very basic project up and running. But then there isn't a whole lot more than that. And currently, that book also it seems to be out of date. The repo is kind of a mess with out of date information, and it's just the information is all over the place. There isn't like a proper that isn't a proper resource to rely on if you are trying to learn no STD Rust for the ESP32. Okay, now I have this module. Hold on. I'm gonna show this module on camera. I don't know how well that showed up. Yeah, so this is an RFID module, specifically RFID RC522. Give me a second. Let me put the thing back into the packaging. I was looking at this module yesterday because I was wondering if I would find it a little easier to solder the header pins onto this and then maybe, work on some projects with this. And I was curious if there are already no STD embedded HAL compatible drivers for this specific module. So I started looking it up, and that in the Google search results, there was there was a there was a link to a docs site for esp32.implerust.com, and that's where, like, within that book they had a section for RFID related stuff. Initially, I was like, I wasn't sure what the website was about. And then once I opened it and I looked at it, initially I was just focusing on the RFID information that I was looking for, right? The RFID module related information. And then I looked at the actual book and I realized that, holy shit, this is an actual resource for ESP32 Rust programming. And then I went and read through the entire book, and it blew my mind that this is the book that I had been looking for. This is the information that I had been looking for all this time. I was looking for information on both ESP32 and ESP32 Rust, as in no STD Rust. To be fair, ESP32 Rust doesn't necessarily always mean no STD Rust. No STD Rust with ESP32 basically means that you are using ESP HAL instead of using ESP IDF. Um, what was it called? Oh, instead of using ESP IDF HAL, you're using ESP HAL. So you are not relying on any kind of like standard library or any sort of framework that provides you with a standard library. Um, what was I talking about? What was I saying? Anyways, so I'd been looking for a resource that teaches you all about both the ESP32 itself, because it has various parts in it. It has or various concepts that you would need to dive into, such as the ADC, the analog to digital converter, GPI opens, which is general purpose I opens, um, your PWM, pulse width modulation, and there's even higher level stuff like Wi-Fi and Bluetooth. Then there's the communication protocols, I2C, SPI, and whatever others there are. All of these things, there are various concepts to explore, right? And I'd been looking to learn all of that. And more specifically, I wanted it to be connected to Rust. I was looking for a resource that teaches you this using Rust. And this is the book, ESP32.implerust.com. I don't know why this book is not more widespread. It really should be. In fact, I'm gonna show you guys the how do I want to go about this? Let's do something here, okay? I am gonna create a window to display. Well, okay. The thing is in the bottom left. You guys can see it in the bottom left. I'm just gonna bring up the repo. This is the book. Wait, is this the book? This is not the book. This is not the book that I was looking for. Back up. I need to hide the browser real quick and open up that. Yeah, give me a second. I'm looking. There it is. ESP32.implerust.com. All right, I'm just gonna open this up, and once the thing is loaded, then I can show it to you guys. Because this is holy shit, dude. This is a gold mine. When like I'm not even exaggerating when I say, at least for me, this is a gold mine. And for anyone else, for that matter, who is looking to get into ESP32s and getting to looking to get into um, learning microcontroller programming through the ESP32, this is a gold mine for you because this teaches you this teaches you about embedded Rust programming through the ESP32. So give me a second here. I'm just bringing up the intro page. I'm also going to open up the book, or sorry, the book's repo. I mean, okay, Impel Rust, Rust embed book. Uh, this was not what I was looking for, so I can close these two. And yeah, okay. So let me bring this back. All right, so this is the repo. This is the repo for the book. It is ESP32 book by Impel Ferris, and or well, the Impel Ferris is the GitHub account under which you'll find this repo if you are looking for the GitHub repo. And this is the book, Impel Rust for ESP32. You can find this at esp32.impelrust.com. And dude, when I tell you this book is a gold mine for anybody who is looking to learn about the ESP32 through the use of no STD Rust, I'm not exaggerating about that. This is a gold mine. If you are looking to learn about both the ESP32 and embedded Rust programming, this is this is going to be a gold mine for you. In fact, I, I I think even if you are completely new to microcontrollers, this will also teach you about microcontrollers in general. It covers microcontroller concepts, general microcontroller concepts, because stuff like ADC, GPIO, PWM, I2C, SPI, all of this stuff, these are general purpose microcontroller concepts. They are not ESP32 specific, because ESP32 itself is a microcontroller. So if you learn the concepts in some other microcontroller, and then you come to ESP32, you will know what those concepts are. You just need to learn how to use them in this specific microcontroller. So I don't think I'm wrong to say that if you're completely new to microcontrollers, this can still benefit you. And especially if you are coming from a Rust background, like you know Rust and you don't want to get into like C++ or MicroPython or anything like that, then you'll definitely this resource will benefit you big time. So yesterday, I after finding this dude, I spent the next couple of hours just going through the entire book. I didn't read like every single thing, but I definitely went over maybe 80% of the pages, which was most of what I found like most of what I felt like I would eventually want to get into. So they cover various things. Something that I loved about this is that so when we go to create a Rust project for ESP32, usually we use ESP generate because ESP generate uses it presents you with a TUI, and you can before the TUI is presented, it'll ask you for a project name. It'll allow you to choose a chipset or a chip. It'll allow you to choose a chip, and then it'll launch the TUI in which you can select whatever features you want. You can set up basically these are settings for your project. These settings will determine what details, what files get generated for the project. And then once you have selected all your settings, you just you hit S to save it, and the project gets created by this tool for you, right? It creates a whole bunch of things with a whole bunch of details, and that's great because you don't have to write any of that manually. You don't have to go into those details manually, but it's good to know those details. You don't have to do it manually each time. Eventually, you can learn how to do it. Eventually, you can start using ESP Generate, but learning to do it at least once, it helps you understand the various moving parts that are involved. And this book does exactly that. It makes you create a bare bones project and then turn that bare bones project into an ESP32 project through the use of creating or populating your cargo file and creating a Rust toolchain file and whatever other files are required. It it teaches you about all of that. Not only that, it goes into because there's boilerplate code that gets created within the project when you use ESP Generate. It even makes you write that boilerplate code from scratch, teaching you what each and every thing does. And dude, that is mind blowing. Also, I just saw the word abstraction layers here, and I wanted to go into this as well. This teaches you about the abstraction layers. Look at this diagram, dude. This is, yo, the information in this book is insane. And I, at this point, have basically found what, hold on, give me a second. Okay. At this point, I have found the book that I was looking for. This is the book that I've been looking for. I didn't know I was looking for this, but this is the book that I've been looking for, and this book needs to be more widespread, dude. Uh, because it when somebody looks up ESP32 Rust, this is the book that should be coming up. Because the other book, as great as it is, the No STD training book, as great as it is, it's not complete right now, and it's also broken. As in, you go to the repo and the information that you see there versus the information that you see on the no std training in the no std training book, it's completely different. So that thing is still being worked on right now, and in the meantime, This book is a gold mine because, dude, okay, this goes into the introduction, right? And it mentions that we'd be using no STD because, well, not I'm not going to say because, but um, it mentions that we're going to be using no STD, which is also why this is a gold mine for me because I've been looking for no STD for the no STD approach, not the STD approach. So, aside from the introduction and the whole STD no STD thing, it then goes into various concepts: PWM, how to use PWM to create effects, ESP Also, this is where we explore Embassy for async coding. Then it goes into, I believe this is also using PWM. So it uses a buzzer. In this case, it's using so in my case, I'm going to be using a piezoelectric diaphragm to create the buzzer kind of effects. Here, it's using a similar thing. I don't know if that's piezoelectric or not, so I can't say anything about that. But it is a buzzer, and that buzzer is being connected directly to the ESP32. The great thing about all of the topics, like it covers various things. So okay, you have buzzer, you have voltage divider, ultrasonic. This is where the ultrasonic sensor comes in. Um, you have a PIR sensor. Fortunately, I happen to have one of these from like ages ago. Then servo motors, then ADC, LDR. LDR is our light sensitive, light determined, I think. Yeah, I think light determined resistor. Um, we have an LDR, then it goes into Wi-Fi, I2C. I2C is the communication protocol. Then it goes into OLED display. I don't have one of these displays. I'm definitely going to be ordering a couple of these because these are small but cheap as hell. These are small but super cheap. I need to order these displays and a couple of the other monochrome displays as well because I can use them for various purposes. Then it goes into thermistors. Thermistor is a temperature controlled resistor. SPI, another communication protocol. Then it talks about the SD card. So, because like the ESP32 does, sorry, I just remembered that I didn't open up my chat. So give me a second. Let me open that up real quick. And all right, we are good to go. Okay, so yeah, the ESP32 does have support for SD card related stuff. I don't remember if it's to connect it directly to the SD card or if it's meant to be connected to, or if it has support for talking to the SD card modules, because I do have an SD card module, a couple of them, in fact. And yeah, we'll find out later on which one exactly it is. Then there's RFID, which is exactly what I was looking for initially. Um, then joystick, Bluetooth, LCD, and e-ink, as an e-paper, and then TFT display. I do have a couple of these displays. And then it also goes into Ratatouille, and I haven't looked at the projects section yet. Now, what I was saying is, in each of these, just a second, I just realized something that I forgot to change. So I'm just gonna change that. Okay, so um, wait, let me open up my chat again. I had to change something because of which I had to close the thing. And we are back. Okay, so notice here in each of these, or in most of these sections, it also mentions circuit. So you have the buzzer, and then you have the circuit that you're going to be setting up. For example, like with the buzzer, then you have with, let's say, fading LED. Actually, this, I think fading LED was just a simple circuit, so they didn't really need a separate section for it. They did have a diagram. I believe they had a diagram for it. Uh, oh, the diagram was not done initially because for the fading thing, they tried to use the onboard LED because the ESP32 does have an onboard LED that's connected to one of the GPIO pins. I don't know if you can use that for PWM though. I guess we can find out. But yeah, I believe it is connecting it to it is trying to control the onboard LED first, and then it goes into an example using an external LED, and you have a circuit for this as well. If we are talking about, let's say, um, I think I showed the buzzer, didn't I? Yeah, I think I showed the buzzer. If we're talking about the ultrasonic sensor, you have the circuit being shown for that as well. This is great. This is why I'm saying this resource is a gold mine for people who are looking to get into ESP32 Rust development, because this takes you from the very basics uh, up to more advanced stuff. By the time I've done all of these, and I plan on doing all of these, well, at least the ones that I do have, like the ones that I do have the hardware for, because um, I do not have an OLED display. Which specific one is the? Yeah, this is the one that I want to order because these are pretty cheap. Um, and I can use this for various purposes, like in situations where information needs to be displayed. I can definitely use this because I'm going to be getting into doing robotics stuff after becoming more comfortable with the ESP32. Um, with ESP32 and Rust programming. I'm going to be going into robotics stuff. So I would definitely like for there to be a couple of displays. And the cheaper the displays are, the better it is because I do not have a lot of money to spend on this. So, okay, this is an OLED display. Another display was the monochrome display. I don't know if that shows up anywhere. Maybe that shows up under LCD. Yeah, okay, this is an LCD one. For some reason, when this said LCD, my mind went towards something in color. But yeah, I do have this. In fact, I think I have exactly this display because I remember these things at the top. Um, yeah, I believe I have exactly this display. So I have this one. So we can explore this. I don't have the OLED display, so I can't go into that, which that's fine. Um, then I also have for the SD card. Actually, let's take a look at the circuit that's being shown here, and then we can determine if. Okay, yeah. So this is I have exactly this module, which is great, awesome, and it's got the headers soldered on already, so we can just like plug it into the breadboard and get started. So that's great. Then the servo motor. So I was talking to Gemini about this. I do have servo motors. I also have servo controller modules, but this specific example or this section is teaching us how to control the servo motor directly from the ESP32. And I wasn't too sure about how good of an idea that is. So that's why I was talking to Gemini about. So here you can see the circuit that we'll be making. I wasn't too sure about like how safe that is because of how much current servo motors can pull. So I'm still talking to Gemini about this to see like what the situation is. It could just be that, one servo module is fine, but then multiple servo modules would end up putting a very heavy current load. So yeah, I do have servo motors, so we can definitely go into this as well. I So with joysticks, I don't have this specific thing. I don't have. I do have joysticks though that I would need to hack, but I don't have this. So I don't think we can do this section, the joystick section. Um, I don't have a thermistor, so we can't do the thermistor section either. I don't have um, I don't have an e-ink display. I don't have e-paper, so we can't do that one. However, I do have a couple of these TFT displays. I have four of them. Yeah, in fact, they're these exact ones. Two of them are one model, and two of them are a different model. I can't remember which one is which, but yeah, I do have these. I believe I have this one, ILI 9341. Two of them are this, and two of them are something else. I can't remember what that is. So we can do this as well. I have the RFID module. I showed that earlier on camera. Then I'll be getting into Ratatouille as well, and I think from this point on, like once we get to this section, by the time we get to this section, I will already be fairly comfortable with doing doing ESP32 stuff. So um, regardless of what hardware this actually, I don't think this is meant to be hardware dependent. I think this is more so pushing us towards the coding side of things. I could be wrong though. I don't remember. No, I don't know. Not even that. I don't remember. I don't know. Either way, I think once we get to this point, we should be able to just decide. We should be able to choose which display we want to use, because we'll have Explode, LCD, TFT. Actually, those are the only two displays that I have. But yeah, we at this point we will have Explode, TFT, and LCD already. I think for this purpose, I might go for the TFT because it has color and higher resolution. But yeah, this is like all the way at the end. And this is also using mouse food, which I've mentioned in the past. This is the um, okay, yeah, I was about to like think about how I should describe this, but it's mentioned here. It's an embedded graphics backend that brings Ratatouille to microcontrollers. So this basically uses embedded graphics to allow you to use the Ratatouille API to build stuff for microcontrollers, build TUI for microcontrollers, which is great. It's amazing, and I'm excited to test this out. Okay, so we are gonna go from the beginning, and I do want to set up, because in the past I have been curious about what the various different settings are that are being set up. I mean, for the most part, I kind of know them now, because like in the cargo file, you have to mention your you have to mention what the target is. You have to mention the uh, the dependencies. The dependencies are usually okay. I was about to say that I usually add them using cargo, but no, that's not true. I usually select them with ESP generates TUI. There's a couple of other things that get created as well. There's the NeoVim integration that needs to be created. I don't think that's going to be created in this case, but I think ESP generate is what. Um, where was I going with that? Yeah, no, ESP generate does create it. I don't know if IntelliSense is going to work well. I guess we'll find out, right? We'll find out once we get to that. But I want to go over this entire book. And this is, dude, I'm so excited about this because this is what I've been looking for. How is it that this did not pop up when I was Googling ESP32 Rust for so long, this did not pop up? Or could it be that it popped up and I just didn't see it, or I saw it and I didn't want to open it because I wasn't sure what the resource is? That's a possibility, but I think I would have remembered seeing this. I don't think this popped up at the time. And at the time, what did pop up was the, Rust ESP book and embedded Rust book, and then the no STD training book. In fact, no STD training book, I think even that doesn't pop up that often in the Google search results, or it didn't pop up that often back then. I had to find it through the ESP Rust book. But yeah, okay, so we're going to be getting into this, and we are going to be doing our Rust ESP32 projects using this book. The great thing here is that this explains the various concepts as well. Like, let's say we go into PWM, pulse width modulation. This explains everything about PWM. It doesn't just show you how to use the PWM API in ESP HAL or wherever the API is. It actually explains the concept to you. It goes into the math as well, explaining all of this. And then finally, you go into the code of it using, whatever is provided by the microcontroller. Wait, where's... Oh, so far it's still explaining all of this. Actually, I think... Oh, wait. This is explaining the various other tools that the ESP32 has that enable PWM related operations. In the fading LED thing is where we go into the code and actually start using PWM. And this, dude, I'm so excited about this because just like this, just like PWM, even other concepts like so there's voltage divider, it goes into voltage divider as well. There are other concepts like ADC, for example. It goes into ADC, it explains how things work. Look at all this. Like, dude, um, it goes into SPI as well. I don't know how deep it's going into it, but it ex, um words. It explores it. It introduces you to the concept so you're not completely blind to it. It explains it even if it's on a higher level. It explains how things are working. Here it's explaining I2C, how I2C is working. And additionally, it also gives you other resources, which are like not part of this book. It gives you other resources that teach you how this protocol or whatever this mechanism is works. Where's the SPI section? There was something for SPI specifically. Yeah, here. Here it's teaching you about SPI as well. Earlier there was a thing about I2C. So like, dude, this is a gold mine. I cannot state that enough. This is a gold mine. If you are looking to learn embedded Rust programming, no STD Rust programming, specifically for the ESP32, this is amazing. And from what I understand, just like this, this is a community. This is a community that has worked on this book, and there's a couple of other books as well. There's there's a microcontroller that goes by STM something something. I don't remember exactly what it is. Hold on, wait. I opened up this thing, right? If we go to Impel Ferris, in the Impel Ferris on the Impel Ferris account, they have a list of repos. They have stuff for ESP32. They have for Pico. They have for RP2040. They have maybe one or two more. I remember seeing one or two more. I don't remember, but yeah, you have books for these various things. It's not just the ESP32 one, but I'm more interested in the ESP32 book. I'm excited, dude. I don't know if you can tell how excited I am about this, but I'm excited. Now, before we begin, we're gonna get right into this. We're gonna read through this entire book. Before we begin, I need to take a short break, and I'll come back, and then we're gonna start. I'll be back in like 2 minutes. All right, I'm back. Uh, Give me a second here. I just need to check something. What should we be opening up here? Actually, wait. Um, yeah, okay, we're good. Cool. So we're gonna start by reading the introduction, and yeah, then you guys are gonna see how great this book is as we keep exploring this book and learning about embedded programming, about microcontrollers, about the ESP32, and about um, no STD Rust programming for the ESP32. Okay, so intro. In this book, we use the ESP32 Dev Kit V1 with Rust to build simple and fun projects. The ESP32 is a popular microcontroller for IoT applications, and we take a hands on approach to help you learn by doing. You will explore how to turn on an LED when the room gets darker using an LDR, use an ultrasonic sensor to detect when something is close, control an LED through Wi-Fi, draw images/text on an OLED display, play songs and alarm play songs and alarm sound with a buzzer, control a servo motor, and more. We'll use Rust's no STD environment. While it's possible to program the ESP32 in a STD environment, I feel it's better to start with no STD as it enables you to apply the same logic when working with other microcontrollers. I am so glad that they made this decision because this helps a lot, like a lot. I'm damn sure that so many of the projects that a lot of people are working on, they prefer to do no STD instead of STD. I don't even know about all the projects that people have worked on, but solely because of the very low level access that no STD gives you, and because of the how do I say this? Because of the fact that you're not going to have the added overhead of the ESP on top. Because of that, people would prefer to go with no STD. And in general, I feel like people would prefer no STD because it might give you more control than what what STD would give you. But of course, there is the disadvantage. To be fair, okay, I haven't explored what all SCD does give you. I know that it gives you higher level stuff, which you wouldn't have if you were using a no STD environment, and that's why there's a bunch of things that we have to do manually in the no STD side. I know about that, and I know that to a certain extent there might be some overhead as well. And when you're working with something like the ESP32, which is already a resource constrained device, you probably want to squeeze out as much power as you can out of it. I feel like that would be a good. Hold on, maybe wait. We're gonna take a quick detour and ask Gemini. So give me a second here. Just real quick. Not gonna waste too much time on this, and then we're gonna continue. Did I unmute my mic? Let me just make sure. Check, testing. Yes, we're good. Okay. Hey, so I'm learning no STD Rust for ESP32. But this has me wondering about what the STD side of ESP32 Rust would be like, what all it provides, and what are the pros and cons of it. Okay, transitioning from no STD to STD on the ESP32 is a bit like moving from a minimalist workshop to a fully stocked factory. While no STD gives you total control over every CPU cycle, the STD approach, often called the hosted approach, leverages the massive ESP IDF, which is the IoT Development Framework, C stack as its foundation. In this mode, the ESP32 effectively runs a real operating system, which is free RTOS, and Rust treats it more like a tiny specialized computer. The architecture. The STD ecosystem is built on a sandwich of libraries that bridge Rust's standard library to the ESP IDF-C code. Okay, the key components, ESP IDF sys, this is the raw unsafe bindings to the ESP IDF-C headers. ESP IDF HAL, this is a hardware abstraction layer that implements the embedded HAL traits using ESP IDF calls. ESP IDF SVC, this is the quote unquote secret sauce. It provides high level idiomatic Rust wrappers for complex services like Wi Fi, HTTP servers, MQTT, and NVS, non versatile storage, non volatile storage. Okay, what STD provides? When you use STD, you gain access to the features you'd use in desktop Rust, such as collections, which is vec, hash map, string, etc. They work out of the box because a global allocator is automatically set up. Then you have threading using STD thread. It maps directly to free RTOS tasks. Then synchronization, mutex, RW lock, and convar are available and integrated with the OS scheduler. Networking, you can use the STD net module for TCP/UDP, or better yet, use ESP SVC for managed Wi-Fi and HTTPS, and floating point standard library math functions just work. Pros and cons. The pros are ease of use, okay, networking, binary size. Well, okay, hold on. It's given me a table here. Binary size would be large, whereas no STD's binary size would be smaller. Boot time is slower because it waits for the OS/IDF to initialize. And with no STD, it's near instant. Control, you have abstractions that can hide low level details, whereas with no STD, you have absolute control over the hardware. Then runtime, it uses free RTOS, and with no STD, it's bare metal. The catch, the safety gap, a common misconception is that STD is safer because it's higher level. In reality, because STD sits on top of a massive C code base, a mistake in the C layer or an improper wrapper can still cause a hard crash or reboot. For example, if you try to use the Wi-Fi stack because the system event loop is initialized, the underlying C code may trigger a fatal error that Rust's borrow checker can't prevent. In no STD, since more of the drivers are written in pure Rust, you often get more compile time safety for hardware for the hardware itself. Okay, hold on. Um, is there any overhead difference between STD and no STD? The difference in overhead between STD and no STD on the ESP32 is substantial because they represent two entirely different execution models. In no STD, you are writing bare metal code that runs directly on the hardware. In STD, you are writing a hosted application that runs on top of the ESP IDF, which is a full C-based operating system based on free RTOS. Okay, so the binary size would be bigger. Um, with STD, it would be bigger because no, a basic project would be typically around 400 KB to 800 KB. And this is because it includes the free RTOS kernel, the new libc library, and the Rust standard library's internal machinery for threading and panic handling. RAM usage. The memory footprint follows a similar pattern. With no STD, you have nearly the entire SRAM available. You manage the stack and the optional heap yourself, and static memory usage is negligible. Holy shit, why was that so hard to say? Um, Static memory usage is negligible. With STD, the ESP IDF consumes a chunk of RAM immediately for its own internal tasks like the idle task. I mean, this makes sense, right? Because if you essentially have an OS running on top of the hardware and then your program is using that OS, you have the overhead of the OS itself, right? So if you are talking about an already memory constrained device, then you kind of have you're kind of going to have issues if you are then introducing the overhead. However small the overhead may be, you are still introducing a bit of an overhead, and so that's resources that you could have otherwise been using for other stuff, right? Okay, the ESP IDF consumes a chunk of RAM immediately for its own internal tasks like the idle task timer task, the system event loop. By the time your main starts, several kilobytes of RAM, keep in mind, um, the ESP32 usually has megabytes of RAM. Uh, Justice, hello, hello. Welcome to the stream. How familiar are you with Rust? I would say I'm still very much a beginner. I'm still learning Rust. I'm comfortable with the language at this point, but I'm still learning. I have to explore. I have explored smart pointers, but I haven't really dived deep into it. Um, yeah, I would say I'm still a beginner, but I'm already working on various projects with it, and hopefully at some point soon I'll finish. I actually have this. Hold on. Wait, no. If I try to load that right now, it's gonna slow things down. But yeah, I have a sort of syllabus that I'd designed through Gemini, so Gemini can then teach me a bunch of the the topics, uh, pretty much similar topics to what you can find in the Rust book. Also, ESP IDF inits buffers for like Wi-Fi and stuff. Oh, are you asking how familiar I am with that? Not at all. I haven't used. That's actually what I was looking up right now. Um, I was trying to figure out like, is the STD side of Rust going to be more heavier than no STD? And if so, why and by how much? And it turns out, yeah, it is quite a bit. That's what I was just reading right now. Hold on. Execution and performance. Boot time. No STD boots almost instantly. STD has a noticeable delay, which is milliseconds, as the ESP-IDF initializes the flash, um, set up the dual-core environment, and starts the scheduler. Interrupt latency. In no STD, you handle interrupts directly via the hardware vector. Latency is minimal. And in STD, Gemini, I recommend doing rustlings if you haven't before. Yeah, I've done it. I actually discovered rustlings after I got into. So I'd seen rustlings being mentioned. I did try doing the the Rust book, because they have an excellent book aside from Rust by example. Um, they have an excellent book with like lots of details about the entire language itself. But I found that to be not that good of a fit because of my attention issues. So instead, what I did is I told Gemini to generate a sort of syllabus for me, and the syllabus was basically all the Rust topics, going from beginner. So okay, when I generated the syllabus, at that point I already knew the basics of Rust, kind of the basics of Rust. So that helped me a little bit, but for the most part, yeah, Gemini Gemini teaching me this did help, because through Gemini I was able to make the specifically Gemini CLI, not even the web version. But yeah, through Gemini, I was able to make these chapters smaller so that I can consume it without getting distracted. And then I can also practice it, because then Gemini will give me like an exercise. And after that, we can move on to the next thing. I discovered rustlings later on, or rather, I should say, I tried rustlings later on. I'd found rustlings early on when I was learning Rust through the Rust book, but I didn't try it out at the time. It is, yeah, you're right. It's actually a pretty good thing for. It is actually pretty good for practicing stuff. I was recommending that as well. I don't know if I have that on this system. I think I do. Maybe. Hold on. I might have to boot it up. Wait. I recommend doing rustlings if you haven't before. It's going to be heavy. heavier, but only by the stuff you use. That is really comparing ESP-IDF with bare metal, not STD and no STD. Okay, yeah, that's fair. Not really a fair comparison. So when I was talking about STD, I was actually talking about ESP-IDF because when you're using STD, at least on this side, because I'm doing specifically ESP32 stuff, you are using the ESP-IDF, and when you're using no STD, then it's bare metal. So I wasn't really seeing a difference between them, but yeah, okay. Can you show us what you are reading? So I found this book, this amazing book. Um, Hold on. Yeah, so you can see this in the bottom left of the screen. I don't know how big the text is. I hope it's big enough because I've made the browser window kind of small. But what I'm reading is this book called Impel Rust for ESP32. And this is an excellent book because um, this teaches you about not just no STD Rust for ESP32, it also teaches you about uh, the ESP32 itself and various microcontroller concepts. So stuff like, PWM and ADC and the various serial communication protocols and all, it teaches you about all of that. Oh, it's that tiny window. Can't really read it to be honest. I can try to. Yeah, hold on. I can make it bigger. I haven't made it that big because I wasn't sure um anyone would be reading it. I'm actually okay, wait, no, hold on. I'm gonna be reading this out later on. Give me a second. Oh, let me finish reading this thing, and then I'll be getting into reading this book. So I guess I won't need to make it all that big because like I'll be reading it. I'll be reading it out. Okay, so which should you use for your project? If you are building a battery-powered sensor that sleeps 99% of the time and needs to wake up instantly, stick with no STD. If you are building an IoT gateway with a web server, Wi-Fi configuration, and complex JSON parsing, the overhead of STD is well worth the massive boost in productivity. That's a good comparison. Actually, yeah. Because I guess there it matters like there you have to decide whether you are trying to squeeze as much as you can out of the hardware or if you just want to do the higher level stuff. And it seems like ESP IDF or STD is gonna help you do that a lot more easily than if you went the no STD route because um, there's various things like the heap, I guess, for example, that you would have to do in different ways if you were using no STD. And I want to get into that as well. Hold on. I think maybe they introduced that as well because ESP, I think it's called ESP ALEC that you would use to be able to do something similar. Okay, now we can get into this Impel Rust for ESP32. Give me a second, just like 2 minutes, and then I'll continue reading this. I just need to look something up. Yeah, ESP alloc is the one. ESP alloc is a allocator for the ESP devices. Then you can use stuff from the alloc crate. So I I think I know about VEC being provided, but I don't know about what else ESP alloc. Oh, you know what? I have the thing over here. Let's go. Will this let me go like one step up? Or maybe, okay, hold on. Actually, wait, is all items gonna no, it's not. So just a second here. What was it? It was under projects. Rust. Yeah, okay. So, um, here we have Alec. Okay, a no STD heap allocator for RISC-V and extensor processors from Espressif. It supports all currently available ESP32 devices. Note, using this as your global allocator requires using Rust so and so so and so. Okay, all right. Um, wait, I think I can just ask. Oh, yeah. I uh I have a thing where links are not allowed in the chat. But yeah, you can just tell me what to look up. Docs are wait, no, you had something typed before that as well. STD is kind of split into three parts. Core, which is always available and doesn't require system specific stuff like an allocator and doesn't interface with the OS. This provides, for example, standard primitive types, option and result. Alloc only requires an allocator, i.e., can allocate memory on the heap, which is required for like VEC and box and so on. And then the full STD interfaces with OS level stuff for files like for fi- for like files and sockets and so on. Okay. STD is a superset of alloc and core and includes both. Wait, are you talking about in general or in terms of the ESP32? Because you know what, actually, okay, that makes me think. That makes me wonder. Like, okay, when I was looking into STD Rust for ESP32, which I've looked into it very, very little, but I don't think I looked into exactly what all would be included when it comes to, because e, uh, STD Rust for ESP32 would still have certain limitations, even though you are, interfacing with, even though you are like essentially running it on an OS, you would still have certain limitations in terms of what you can and cannot do because you are not running it on a computer. Kind of running it on a computer, but like there would still be certain limitations. I haven't looked into what those limitations would be. Okay, okay, hold on. I was looking into something here. Okay, okay, because so and so, so and so, so and so. Uh, I just spelled this thing wrong. Okay, ESP alloc just provides an allocator which is required to be able to use the heap and then allows you to use the standard library's alloc crate, which is provided by standard Rust. Okay, okay. Okay, so I'm looking into what all ESP alloc is going to provide. It says it enables the alloc crate. Without an allocator, you are limited to fixed-sized arrays. With ESP alloc, you can use dynamic data structures like vec, string, B-tree map, and box. Okay. Heap initialization, it provides a simple way to define exactly how much of your internal SRAM should be dedicated to the heap. And static allocation, you can initialize the allocator globally using so and so, making it available throughout your entire application. Small footprint, it is relatively simple first fit allocator designed to be lightweight, which is crucial for resource constrained microcontrollers. Why use it in embedded development? We usually prefer static allocation. Okay, yeah, that's fine. As I said, you can see the docs for the individual crates under docs.so-and-so, so-and-so. See the alloc page to see what it adds. Okay, all right. Uh, there was one more thing. Okay, cool. Right, let's get into uh, this. I think the point where I'd gotten distracted and branched out into looking into exactly what all comes under STD was here. We'll use Rust's no STD environment, which again, I'm glad that this book is using no STD because I'm planning on using no STD as well. While it's possible to program the ESP32 in a STD environment, it feels better to start with no STD as it enables you to apply the same logic when the same logic when working with other microcontrollers. Prerequisites, if you haven't already read the Rust on ESP book, highly recommend doing so first. While this book will cover some aspects of setting up the development environment and basic concepts, it will not go into as much detail to avoid unnecessary repetition, as these concepts are already thoroughly explained in the official book. I also recommend you read the Embedded Rust book. I think I read both of these to a certain extent. I've definitely not read them completely, but to a certain extent, I have read them. And I think one of these two books, I can't remember which one, it showed that sort of diagram, which kind of helped me understand or kind of introduced me to how you have these like various different parts, like how you have embedded HAL, and then you have ESP HAL, which is implementing embedded HAL. And because you have this sort of standard implementation, because of that, you're able to use something like embedded graphics. And then through embedded graphics, you can implement drivers that would work with various other devices that implement embedded HAL without having to write the drivers for, you know, a very specific microcontroller. Um, yeah, ESP on Rust is the standard ESP book. You should read that for installation. Are you using Plug RS, Probe RS? What ESP chip are you using? I'm using just the ESP32, and I looked into Probe RS. There was a reason why I had decided not to use it. There was some sort of compatibility issue. I remember looking into this. There was a compatibility issue because of which I I discovered that either it's not going to work with the ESP32 that I'm using, or it's not going to work with the tool chain that I'm using. I think it was with the ESP32, the specific ESP32 that I'm using. Maybe it was to do with the CPU architecture, because the one that I'm using uses the Extensa processor. Which version of the ESP32? Um, just the ESP32. It's ESP32 Vroom 32 something something, but it's just the ESP32. It's not like S3 or C3 or H, whatever. Just the ESP32. I can't remember exactly why I decided not to go with Probe RS. Hold on. One of these books might be um, talking about Probe RS, so I can look it up there. Tooling, okay, okay. Probe RS, is it here? Yeah, here. Just ESP32. Okay, yep, yep. Okay, yeah, this might have been the reason. It said USB JTAG serial. So Espressif devices equipped with JTAG serial peripheral can use Probe RS without any external hardware. For devices lacking so and so, for devices lacking this peripheral, you'll need an external programmer like ESP So it mentioned USB JTAG serial peripheral is available in ESP32C6, H2, S3, and C3. While I do have C3 Super Mini, I'm not currently using that. I'm currently using the ESP32. That was why I decided not to go with Probe RS. Okay, where was I here? Oh, actually, there's also something I need to go map crunching contest, like so and so, so and so, so and so. Okay, predictability and resource efficiency. Okay, all right, yeah. I'm just saying because ProBaris is really nice to use in general. Yeah, yeah. In my case, I can't really use it. I think they did recommend it. I don't remember. What all does this offer? It offers a suite of tools for interacting with embedded. There was also something debugging related that this enabled. Um, Using various debug probes with robust support for Espressif chips. Besides flashing and monitoring, it also provides robust debugging capabilities. If you're unsure whether you need it right now, you can skip this. Okay. Does this go into more detail later on? Let's see logging if that mentions ProbeRS. But yeah, okay. Anyways, I mean, I can't use it. Do you have a JTAG adapter, like an external one? Nah, I'm pretty limited in the the stuff that I have when it comes to programming microcontrollers. In terms of programming, and I don't have anything for debugging actually. Yeah, I don't have anything for debugging. In terms of programming the microcontroller, the best that I'm able to do is connected to the computer via USB. That's it. And once I saw that, okay, you'll have to buy so and so thing in order to get this to work, I just let it go. I was like, I can't do that. It's a little more effort than it's worth right now. Maybe in the future, once I get more comfortable with doing ESP32 stuff, and once I start doing more like advanced projects. Right now, I'm still very much a beginner. I'm still at the basics. Once I start doing more advanced projects, if I feel the need to do a bunch of debugging and I find that the current tools that are available are a little too tedious to work with, then I might look into it. Or okay, when I start using the ESP32 Super Mini, then I might. Um, if it is supported, I'm not sure if that's supported either. Because it does say C3 and it mentions some kind of revision. Where is that? Here. I also don't know if I have S3s. Let me see what those look like. I know that I have um, C3 Super Mini. Let me look up what S3 Super Mini looks like. Maybe, well, okay, no, it looks very similar to C3. Hold on. Um, ESP32 S3 Super Mini. They both look similar. Okay, never mind. I shouldn't be trying to look at their. I think I'll. You know what? I'm curious now. Hold on. I'm gonna. Where is it? I have the box here. Wait. Okay, yeah, it's a C3 Super Mini. Fortunately, they've printed it on the back of the board. Yeah, it's a C3 Super Mini that I've got. So at some point later, once I've managed to solder header pins onto it, I might use this. Um, the ESP32C3 just supports you wiring a USB cable directly to some pins and then use JTAG debugging over that. That one is great. Okay, good to know. Good to know. Good to know. I guess I can. I do wanna explore the Super Mini, specifically like the small one that I have. I think I might have bigger versions of C3 as well. I don't know if I have S3. I because I've ordered a couple of ESP32s over time. At the time when I was buying these, I mainly looked for the ones that were cheaper. And it just so happened that this one that I bought was incredibly cheap. And I don't remember if any of them were S3 or C3. I did pay attention to the C3 part when I was buying the Super Mini, but like with the bigger ones, I think most of them are just ESP32. They're not S3 or C3 because I think those would have been more expensive. The ESP32 C3 is actually probably way easier to use with Rust because it's a RISC-V architecture, has a direct built-in JTAG peripheral. With the original ESP32, you need to install and build a different extensor toolchain because that is not currently supported. That is currently not supported in me. I noticed that. Yeah, I noticed that. When I was installing the toolchain, I had to install ESP up, and through that, I had to install the extensor target, the extensor toolchain. And later on, when I looked it up, I found out that, yeah, RISC-V is apparently already part of mainline Rust. And so if I was using, I think the C3 Super Mini is risk. Wait, you did mention that. I think so. Yeah, yeah, yeah. C3 is risk 5, and if I was using this, I would have been able to just use the regular Rust toolchain. But in this case, I had to install ESP up, and through ESP up, I had to install the Extensor toolchain. Though I will say this, I'm kind of glad that it's so frictionless to install because I didn't have as much of a headache with installing these extra things as I was expecting to have. So like I'm kind of glad about that. And I do have a bunch of the older ESP32, so I'm probably going to be sticking with Extensor. Uh, but yeah, again, once I get into more advanced ESP32 projects, I think at that point I'll see more value in the debugging side of things. For now, I'm still like trying to learn the basics of. For now, I'm still trying to learn the basics of using the ESP32 itself. Now, where was I with this? So, meet the hardware. We'll be using so and so, so and so. This, I believe this is the exact one that I have right now connected. ESP Vroom 32. This is the exact thing that I have. I'm glad that later on, hold on. I think that's on the next page. Um, Later on, this person also mentions, or later on, the book also mentions the difference between the dev board, the module, and the chip itself. So this is why I'm saying like this book is great if you are trying to get into ESP32 development and you're a beginner in ESP32 itself. So like you don't have to have because for me I have slight past experience using MicroPython with ESP32, and that's how I kind of got introduced to ESP32. I'm not like a complete beginner, but I'm still very much a beginner, right? For somebody who's a complete beginner, I think they would also benefit from this book because this book goes into like even the basics of these chips, of these boards themselves. Um, do you have a general USB serial adapter? Extensor support is coming to mainline Rust soon, TM, probably in a year or so. Like an FTDI one. No, I don't think I have a USB serial adapter. No, I don't think I do. No. I usually because I'm very much a beginner in like digital electronics and analog electronics as well for that matter. I don't have there's a bunch of these tools that I don't have because I don't work with this stuff very often. Um, I don't know, maybe this might be one of the tools that I might find use for in the future as well, if it's not one of those things that has been phased out because functionality is already included within newer microcontrollers, then maybe I might. Wait, you said yeah, yeah. No, you know what? Okay, MicroPython. I'll say this. I'm glad that I started with MicroPython at the time when I was looking into this, because I do a bunch of Python related stuff. So I am much more comfortable with Python than I was with Rust. I'm like very comfortable with Rust now because I've been doing it for a while. But like back then, I was much more comfortable with Python. And in terms of getting started with microcontroller development and learning about microcontrollers, I feel like MicroPython gives people a much more it gives them a much higher level point to start from. You are absolutely not going to be doing low level stuff. I don't know if you absolutely cannot. I'm not going to say that because I haven't explored that side, but you are not going to be forced to do low level stuff if you are using MicroPython. And that's great if you are trying to do smaller projects, projects that don't require you to squeeze out as much performance from the microcontroller as you can. Hold on, I lost my train of thought. What was I saying? Yeah, you MicroPython will let you do stuff on a much higher level. And when you are first learning how to do microcontroller stuff, I feel like being introduced to it from a higher level is very beneficial. It's, or rather, it's less intimidating because you can like set up, you can set up your project, you can create a script with just a few lines of code, you can have an LED blinking, and just like that, like you've started, you're good to go. You've started. But then with Rust, you have like this massive boilerplate code. Let me open up this project and show. I mean, you probably already know about this, so like you don't need to be shown this, but like let me show other people, anyone who watches this VOD later on. Um, this you have a bunch of like you have a bunch of like boilerplate code, and then in order to do a couple of things, you would then also need to. Well, this is a bunch of ADC related code as well, so it's not like a very fair comparison. But there's a lot of like boilerplate code before you can get started. With MicroPython, it's so much simpler. You can get started very quickly, and you can learn a lot of the concepts very quickly through MicroPython. But then the problem is it's Python, and so if you're looking to do very performance critical stuff, then past a certain point, it's not that great. Um, it's very useful in general. Like the ESP prog is less than $2, actually more like $10 to $15. Sorry, a generic JTAG one is about $2 to $5 though. That's not that much boilerplate for microcontrollers. I mean, okay, that's your opinion on it. I feel like if if I don't know, I've explored MicroPython first, and then I've moved to Rust, and I would very much prefer to stick with Rust. But like if we're talking about a beginner being introduced to ESP32, I would much rather introduce them to ESP32 through MicroPython than through through Rust. Granted, introducing them to ESP32 through Rust is going to help them later on down the line because they'll be able to write performance critical applications. But I feel like getting into it through MicroPython is much less intimidating for somebody because okay, let me also mention this. Okay, when I first started looking into programming ESP32, uh, looking into programming ESP32s, I did explore the various possibilities. I knew that I didn't want to touch the C++ side. Um, I was already very comfortable with Python. So I was like, okay, let's do the Python side. I had like a tiny bit of knowledge in Rust. I wasn't very familiar with the Rust toolchain and the Rust ecosystem and like the various moving parts within any given like Rust project. I didn't know all that much about Rust at the time, but I knew a little bit. At the time when I looked into the documentation, I believe it was, but this was like, to be fair, a good like maybe 2 years ago, maybe more. I don't remember. Maybe a year ago, maybe 2 years ago. I don't remember. But at the time when I looked into it, I was actually discouraged from exploring it further because everything just seemed so complicated for me to follow. Way more complicated than I was than I was comfortable with. Way more. There was so much research to do. There was so much stuff to set up, which I didn't have to do nearly as much. Like, don't get me wrong, I had to do stuff for MicroPython, and there was still a bunch of research to do there as well, even on the Python side. Like, for example, there was information that I only found out about certain types of information thanks to other sources. Like, I remember posting about one of the tools. I forgot what it was. Um, ESP Flash. No, no. There was some tool that I was using. There were two tools that I had to use. I think one was to flash the MicroPython firmware, and the other was to um, upload your script to a running ESP32. One of these two, I don't remember all the details, but there were two tools that, after exploring a bunch, I had discovered that, yeah, okay, this is the workflow that I should be following. You do this, you use this tool, then do that. uh, Things are going to be much less frictionless. I posted about it on X, and then somebody who does actually do a lot of MicroPython stuff, they replied by saying, in the majority of the cases, both of those things or both of those tools can be consolidated down to this one specific tool. I don't remember the name of that tool either, but shout out to that person, because once I got into that tool, I started using that tool over the other two tools, like, completely. I was using only that one tool. Wait, hold on. Um, Fair enough. I'm coming from the C world for UCs. Yeah, I've programmed, for example, the CH32 so and so without any libraries, just bare metal registers. Okay. Yeah, sorry about that. I can't do much about the ads. I guess I'll wait for you to come back from the ads. Then I'll continue saying what I was saying. Back. Okay, welcome back. Yeah. Okay, so you mentioned this thing. I don't know about the. I've heard about this though. The CH32. Let me look this up. And 200 plus lines of boilerplate setup code is crazy. Also, um, not that surprising, because you also mentioned that you were dealing with registers. Um, Hold on. Okay, 32-bit general purpose RISC-V MCU, so and so, so and so. It says this is a mini game console. That's interesting. The CH32 V V003 series is a collection of industrial grade general purpose microcontrollers that utilize so and so RISC core design supporting so and so thing. Interesting. I didn't know about this. But yeah, okay, so I have like very limited C++ knowledge, so little that I can almost consider it like not knowing C++. I mean, I can understand the code, but like, I'm by no means an expert in it, because the way that my journey went was, I went down to, so I was coming from a C sharp background, and then out of curiosity I explored C++, and then out of curiosity, because I was wondering how the compilation was done, and through learning how the compilation was done, I learned that assembly is a thing. So then from the C++ level, I went down to the assembly level, and I started doing assembly stuff. I started learning assembly, and then I kind of just pushed C++ aside because I wasn't interested in that anymore, and I just explored assembly. And I'm kind of glad that I did that, because that taught me a lot. That taught me a crazy amount of stuff about how things work in general. CH32 V003, not CH32. So I'm assuming you're mentioning that because maybe they're two different things. Um, but yeah, the one that I looked up, like when I look up, oh, actually, I did look up CH33. I looked up the one that you were talking about, CH32V003. That's the one that I looked up, and good to know that. Wait, you're saying these are really cheap? Are these? Wait, these are just the chips. These are just the microcontrollers. They are not modules. They are not dev boards. Is that right? Because then maybe I should look up development board. So, CH32 so and so, development board kit. There are multiple CH32 so and so chips. Oh, that's why you were mentioning it. Okay. Yeah, assembly is great. Um, even though I like after learning assembly, literally all I did with it was do a couple of like hobby projects and maybe do a tiny bit of bootloader assembly stuff, 16-bit assembly stuff. Even though I barely ever touched assembly after learning assembly taught me a lot, and that's why I'm glad that I learned assembly, because I explored through assembly. I explored a lot more than just assembly, because without learning assembly, I wouldn't have understood how memory works. I wouldn't have understood what a function prologue and epilogue are. I wouldn't have understood the function stack, um, the function. What is it called? The whatever the whatever the stack is that gets allocated for a specific function, whatever that thing is called. I wouldn't have understood what that is. I wouldn't know what registers are. I would have no idea what SIMD means. I wouldn't understand any of this stuff. So learning about it definitely helped me. And I think to a certain extent, it also, some of that knowledge also helped me on the microcontroller side. Um, Yeah, I use them on my own PCB design. You can get CH32 V3003 dev boards for less than $1 though. Now, is there okay, let me look this up. CH32. See, it being less than $1 is definitely um appealing. So let me look this up. CH32 Rust. What is what's the ecosystem like for this? I'm probably not going to be exploring this all that much. I could be wrong about this. Maybe somewhere down the line I might be interested in it, but I mean I'm planning on sticking with the ESP32, but it's good to know about these other chips as well, just in case if I need something in the future. So it says so and so microcontroller is well supported by the Rust ecosystem with active community efforts providing necessary tooling, peripheral access crates, and hardware abstraction layers. Development with Rust is possible, though it generally requires using the nightly Rust toolchain. Okay, so wait, if something is requiring you to use the nightly Rust toolchain, would that be? I mean, I don't know. For some reason, I kind of get the feeling that I should be I should be I should be expecting breakage between certain versions. I could be wrong about that, but like I don't know. That being said, I'm glad that you mentioned that it's cheap. because I might actually look into this. And also, the amazing thing about Rust is that, installing a new tool chain isn't really hectic. Um, that's one of the reasons why I love Rust, because, like, dude, Rust, I've mentioned this before. It really seems like Rust, the people that designed it and the community that has helped with the maintenance and further building of Rust has been designed to address the downfalls of other, or the negative sides of other languages. It was built to address the problems and the headaches that people faced with other languages. Nightly is relatively stable. I would need to do more research on this before. I mean, look, to be fair, it's not like I'm working on, like, if I am doing microcontroller stuff, um, at least for now, it's not like I'm working on a project that for which I require the tool chain to be absolutely stable for the next year or 2 years or whatever. So even if it is nightly, I don't think it should be that big of an issue. And I think I mentioned this before, that, like, I haven't used nightly as much, so my assumption about there being possible breakages between the two, that might be wrong. Um, but I'll have to look into this more. That being said, as I mentioned, the projects that I'm working on right now, as a complete beginner in microcontrollers, they're not going to be like super serious projects that I need to have, you know, 2 3 years of support for. So even if there is a tiny bit of breakage between updates, um, I feel like I can handle that. So even if I do need to install nightly, I believe I do have nightly actually. Um, Not cargo. What is it? Rust up. Rust up. Tool chain. Was it list? Yeah, I have one of the nightly things. I don't know if there's multiple nightly tool chains, but I do have nightly. That being said, it's called nightly because it's updated nightly. I don't think I have the latest nightly one. Yeah, I probably don't have the most up to date nightly tool chain. It isn't like every other nightly version breaks stuff. Nightly just allows you to enable additional features, opt-in, that can be more unstable. You know what? You're right. What was I trying to compare this to? That I thought that things might break between. No, actually, I don't think I was trying to compare. I think I have actually read this. Probably in the Rust manual itself. That's the word I was looking for. I kept saying Rust book. It's called the Rust manual. Either way, the name it's fine. But yeah, I remember reading. So yeah, first of all, it's exactly what you said, that it gives you access to certain features that are currently being worked on, and because they are actively being worked on, they might be a bit unstable. Um, I do also remember there being a sort of warning that, yeah, things might break, though I feel like that warning might not have been for stuff that already has been developed, but stuff that's currently being developing. So I think I might have confused those two things. And that's probably why I thought that, oh yeah, stuff might break. So I think is only stuff only tends to break if I'm using one of the newer features which is actively being developed, which could change between updates. And then it kind of makes sense that some stuff might break. Um, like the stuff that is, hold on, I clicked on something. Yeah. Like the stuff that is on nightly that isn't feature gated is only stuff that is automatically becoming beta in less than a month. Rust Nightly is very stable in comparison to other nightly channels. What are the other nightly channels? Oh, you mean nightly channels in other frameworks and other languages, or Do you mean like Rust's own other nightly channels? But yeah, yeah. I mean, I turns out I already have nightly, and since isn't this specific CH32 using RISC-V? Yeah, it says this is a 32-bit RISC-V microcontroller with so and so instruction set. Rust has support for this architecture, specifically RISC-V 32 EC. Okay, the tool chain. Development typically involves using the Rust Nightly toolchain and adding the Rust SRC component. The crates available are the pack, the HAL, and okay, there's also a hub for this. Programming and debugging tools. There's WLink and WCHISP, WCHISP, and also Probe RS. This is a recommended open source debugger and Flash programmer for Rust embedded development with support for so and so, so and so. You know what? I'm glad that you mentioned this chip to me, because Zaynar, hello, hello, welcome to the stream. Yes, we are back with the bread. Um, yes, in other software in general. Oh, yeah, okay. So you're saying that Rust Nightly is very stable in comparison to the other nightly channels. That is good to know. That is good to know. That I guess that also explains why some people who are currently there have been certain tools, because I when I'm installing tools, when I'm installing CLI based tools or TUI tools, I prefer to look for Rust based ones first. That's just like a preference of mine. If I can get it in Rust, I'll try and install the Rust one. If the Rust one is if the Rust one has the features that I'm looking for, and it's actively being maintained, and a bunch of people are already using it, then I'll go for the Rust one. What I've noticed is there are specific tools. Like there was a I forgot what the exact name is, but it's a terminal based PDF viewer. I was looking for a TUI PDF viewer to see what that experience would be like. It's great, by the way. Aside from the high memory usage, depending on what what type of depending on the size of the PDF that you're opening, aside from the memory usage, it works amazing. It works great. Yeah, stuff might break more easily. Think of it as like beta testing of the stable releases. Okay, yeah, stuff might break more easily than stable, but it is incredibly stable in general. WCH is the company that is making. Oh, okay, okay, good to know. Good to know. You just get features 1 or 2 months earlier than they land on beta/stable. So it's good to know. It's good to know that this tool chain is much more stable than apparently I was expecting as well. Because I was expecting things to like break in between. I'm still kind of expecting that, but it is a little reassuring that you mentioned that the stuff that's in nightly is usually it seems like a bunch of testing has been done on it before it came into nightly. So it has been made relatively stable before coming into nightly. This is what I'm assuming. It has been made relatively stable before coming into nightly, and then there's still testing going on it, probably still active development going on, and then it goes into stable once it's properly tested for stability. PDF is like really complex to implement correctly. So when I was doing research on this, I realized that yes, because I was getting sick of having to open up these various PDF files and not having something that can easily convert. the data. This was before stuff like dockling came out. I believe dockling is able to do that for you. I don't remember. Yeah, I think dockling is able to do that for you because the idea with dockling is that it's supposed to allow you to convert various types of data into formats that are more easily digestible for LLMs. And a PDF is not that easily digestible, so it gives you, or well, AI tools in general, not necessarily just LLMs, I guess, but that was the idea, at least from what I remember with dockling. And when I was doing more research on it, I learned that yeah, apparently trying to get it right, you can do it, but trying to get it right can be incredibly complicated because there are little quirks here and there that have to be handled. That being said, this specific tool that I found, I forgot what it's called, but I just launched it using TDF. Hold on. Did I install TDF here? Um, yeah, I did. Okay. TDF cargo install list RG TDF. Oh, wait, I do this every time. Okay, yeah, it's just called TDF Viewer. So this is a tool that I had installed. Okay, it can happen sometimes, very rarely. Only if you enable additional features with feature, then it can get a lot more unstable depending on the feature. I wouldn't recommend enabling additional features willy-nilly without researching them a bit and their state. Good to know, actually. That is good to know. And that I guess that further solidifies the need for me to do more research on nightly before touching it, because like this nightly toolchain, I could be wrong, but I think the only reason why I have nightly toolchain is because this specific tool, TDF viewer, this specific tool requires the nightly toolchain. That was the only reason I had to install it. But um, I'm okay with installing that because, as I've mentioned before, the Rust 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 up itself in general, it makes it super easy to install these things and also maintain them. Maintain, rather, update. It makes it super easy to install and manage and update them. It's not like a massive headache to do it, so that's why I'm kind of okay with just installing these various tool chains. There's a bunch of tools that only work on nightly, like Miri, for example. Wait, I've heard of this tool before. Miri is an undefined behavior detection tool for Rust. It can run binaries and test suites of cargo projects and detect unsafe code that fails to uphold its. Hold on. Actually, wait, Gemini also gave a thing here. It's an experimental interpreter for Rust's mid-level interpretation, mid-level intermediate representation. Okay. Used as a powerful tool to detect undefined behavior, memory errors, and data races in Rust programs. Wait, MIR is like the middle of, like, this is before your code is, like, this is one of the stages that happens, right? So there's a couple of things that happen during this stage, and this is, so your code is going to be compiled down to MIR, and then it's going to be run through this. So I'm guessing within, like in MIR form, it's able to find all of these things. It's analogous to using tools like Valgrind for C, C++. Okay, how Miri works. Instead of compiling Rust code directly to machine code, Miri runs the program in an interpreter, allowing it to track execution in detail and enforce strict rules about what contributes valid, what constitutes valid behavior according to Rust's memory model. Okay, which is an official Rust project, github.com/so-and-so. Yeah, Rust generally compiles code, THIR, HIR, MIR, LLVMIR, and then bytecode. I don't think I remember reading about THIR. Maybe that was mentioned. Uh, Wait, that would be like the once the code has been like tokenized, right? As in once what is that thing called? Like where they generate like a syntax tree out of it. I think that's where this comes in, right? Because okay, your code, as far as I knew, your code goes to HIR, um, then MIR, then LLVMIR. I had looked into the Rust compilation thing. This was maybe a month ago because I was confused about why certain errors would pop up only when certain other errors were solved. So like the Rust analyzer wasn't showing all the errors. I purposely made specific types of errors in my code, and I noticed that it would show a certain set of errors and it wouldn't show the other errors. But then when I solved that first set of errors, then it would show the other ones as well. And I did research on this and found out that yeah, it's because as you mentioned, there's like multiple stages. As you mentioned, there's multiple stages, and within each of these stages, if it fails at a certain point, it doesn't actually go further. And because it's not going any further, so it doesn't catch any of those other errors. So that was interesting to learn about. I didn't go too much further in wait. Uh, I'm stupid. It's code HIR, THIR, MIR, LLVMIR, and then bytecode. Okay. THIR is like the HIR when it's fully type checked and everything is explicitly typed. All right. Okay. Good to know. Good to know. I might look into this later. In what situations would I be using Miri? Actually, I feel like yeah, there there would be situations where because this it seems like this is running tests that you generally wouldn't um these it seems like this is running tests that you might be expecting like testers to actually catch, if that makes sense. It's running tests for bugs or leaks or whatever that you would be expecting testers to catch. Like it mentions that here, right? Memory errors, undefined behavior, data races, stuff like that. If it's able to catch race conditions, that's crazy. You usually use Miri when you write unsafe code. Okay, that explains memory errors and data races. Though I feel like no, data races would also occur. Though okay, yeah, this explains memory errors because with unsafe code, you are kind of telling the Rust compiler to back off a little bit and not bug you too much about memory safety related stuff. Data races, though, I feel like that could still occur even with safe code. I'm not sure. I don't know. I haven't gotten to the multi-threading side of things. At least, outside of Tokyo. I haven't gotten into like bare bones multi-threading in Rust. So I have to test that out myself to see if the Rust compiler is actually able to figure out that yeah, you're gonna have a race condition here. Miri is really unnecessary when you only use safe Rust. when you only use safe Rust, most bugs will really be caught by the compiler already. I have noticed this about Rust. Um, the fact that it catches things much better than any other language that I've worked with. Like, sure, that would lead to the compiler bugging you a lot, but it bugs you a lot because, you know, it's catching all of these things that could potentially become an issue. There have been certain situations where I wasn't even I can't give like an example right now, but I have had situations where the syntax was right. I wasn't doing anything wrong, but there was like it could lead to something something bad happening later, and so the compiler wouldn't let me go any further with the thing. I can't remember any examples of it, but that has happened. Okay, um, I'm gonna look further into this CH32 solely because of how cheap the thing is. Um, oh, solely because of two things actually. One, cheap, which is great, awesome. Two, Rust, because I can do Rust related things with it. So I'm probably going to be looking into this at some point later. The interesting thing here is wait, so we have these dev boards. Even the dev boards seem to be pretty cheap, and that is when they are on. That is like so. What I'm looking at here is something that is on only 3% discount, and even then it's cheap. Even then it's like super cheap. This might actually be cheaper than ESP32 as well. I'm not sure. If you are interested with races, with atomics, you might want to look at Loom. Hold on, let me see. Okay, Tokyo RS Loom, concurrency permutation testing tool for Rust. Loom is a testing tool for concurrent Rust code. It runs a test many times, permuting the possible concurrent executions of that test under the C11 memory. Wait, does this work for like bare bones threads as well, or is it specifically for well, yeah, okay, Tokyo is not. I was about to ask that. Okay, is this does this work for bare bones threads as well, or is it Tokyo specific? But I'm not seeing Tokyo mentioned in their example anymore anywhere. So I think yeah, it works for bare bones threads. It might not even be related to Tokyo. It's just the fact that it's made by Tokyo, which Tokyo has made a bunch of other very useful tools as well. I remember looking at their thing and looking at their repo and finding a bunch of very interesting tools. Tracing was one of them. Yeah, tracing was one of them. There were a couple others as well. I don't remember if clap is done by them as well. Is that what it's called? Clap? I think yeah, I think it's called clap. Maybe clap is not done by them, but like I found the one that I'm talking about when I was looking for clap. Yeah, it's probably cheaper than ESP32. It isn't Tokyo specific. Good to know. Good to know. Yeah, no, definitely good to know because um, um, later on in my Rust learning journey, I am going to be getting into bare bones threads or just threads, not Tokyo specific multi-threading. And at that time, it'll be useful to have a tool that helps me find race conditions because okay, so there were like okay when I was doing research on like why I would use something like Tokyo versus just threads. One of the things that was being mentioned was, I mean, there's obviously a lot of much more sophisticated stuff that Tokyo does that I couldn't even think about doing manually. Stuff like work stealing, for example. All of that stuff, no, I can't implement that manually. I shouldn't even need to implement that manually. If I get to a point where I need that, then I might as well just use Tokyo. However, one of the things that was being mentioned was apparently Tokyo, or the way that things are implemented in Tokyo, it's able to prevent race conditions, whereas you can easily make that mistake with bare bones threads. I haven't had a chance to test that out yet, but I did get to the point where we were doing, what was it, mutex and something shared. I think it's mutex and arc mutex. I don't remember, but there was a thing where data races can be prevented a lot more easily with something like Tokyo than with Rust. Did I say with Rust? With threading. Okay, clap is distinct. On ESP32, you probably want to use Embassy for async IO. Yeah, I plan on getting into Embassy as well. Fortunately, this book, this does touch Embassy. I don't know how deep it goes into Embassy though. Where it was somewhere up here. PWM fading. Yeah, here. I don't remember how much it goes into detail with how the code works, but it does touch on it, and fortunately, it does also give you links for useful resources. You want to use an async runtime when you are I/O constrained. You want to use threads when you are CPU constrained. Hold on. You want to use async when... Yeah, true, true. Yeah, I learned this when I was, sorry, I had to think about that for a second. Um, I learned this when I was actually looking into async programming on the C sharp side when I was trying to learn their task-based asynchronous programming pattern. That's when I was doing research on what situations I would need to use async in and what situations I would need to use multi-threading in. And it kind of makes sense because IO isn't necessarily always a CPU kind of thing. IO is often hardware constrained or hardware bound. That's the... so IO is often like you are limited by the amount of time that the hardware itself is going to take, hardware other than the CPU. So it's not that your CPU is sitting there crunching numbers and that's why it's taking time. It could be something like, okay, reading a file from the hard drive is taking time, or receiving data over a socket is taking time. So it's not necessarily a CPU number crunching problem. So async works great for that. But if it's actually a CPU number crunching problem, then yeah, you want to use multi-threading. Tokyo won't be able to prevent all data races. That is in general equivalent to the halting problem, i.e., not something you can implement efficiently. Data races are something different. They're usually prevented just fine with Rust's send and sync traits, also in threads. Like IO is writing to disk, handling... Wait, data races are something... Wait, data races and race conditions are different things? Hold on, let me look that up. Okay, race conditions and data races are both types of concurrency problems, but a race condition is a general logic flaw where the program outcome is timing dependent while a data race is a specific low-level situation involving unsynchronized simultaneous access to the same memory location. I think I've been using the term race condition wrong because I've been referring to data races as race conditions. Because when each time I said race condition, what I was thinking about was this kind of thing, where you have one location in memory that is being written to and read from like simultaneously, and so whoever is reading it, they might not get the accurate value, and then you get like a that's where you get what I thought was a race condition. But it turns out race conditions are more general. It's not specifically a data thing. A race condition is a semantic error in which the correctness of the program's output depends on the timing or interleaving of events that are not guaranteed to happen in a specific order. Okay, so then a data race would be a kind of race condition, not the only kind though. Is that right? I think that would make more sense. Okay, race condition is like you are checking for something, then somebody else modifies something in between, and then what you are doing after the check fails. Yeah, that's what I was assuming a race condition was, and that's what I was assuming a race condition only was. And I think this is because of my lack of knowledge in multi-threading, because I haven't dealt with too many race conditions. Um, okay, programmers use synchronization mechanisms like locks, mutexes, semaphores, or atomic operations to ensure critical sections of code are executed mutually exclusively, thus controlling the order of operations and preventing these flaws. A data race is a more specific, low-level technical condition defined by programming language memory models that often leads to undefined behavior or memory corruption. A data race occurs when two or more threads concurrently access the same memory location. At least one of these accesses is a write operation, and the accesses are not synchronized by a happens before relationship, i.e., not using proper synchronization primitives. Consequences: this can lead to a very weird and unpredictable behavior, such as a memory location holding an arbitrary combination of bits from different writes, or program crashes. Programming languages generally define this as undefined behavior to allow compilers and processors to perform aggressive optimization. Yeah, I think data races are a specific kind of race condition. Like race conditions is also the general case where you act on, for example, files. So each time I would hear anything about race conditions, my mind would immediately go towards something like that. Um, not just in memory, but like in general, the idea of like, okay, two threads have to access one location, be it a memory location or even reading or writing a file, right? Two threads have to do, they have to read from, or the two threads have to operate on the same location, be it reading or writing. And um, because whatever they're doing is not necessarily synchronized, so one of them is going to get what could be considered like an older value or a wrong value or some sort of that's how you get like an undefined behavior because you don't know what it's reading in that moment. That's what my mind would go to each time I would read race condition. And that's also why I thought that data race, because it says data, that's also why I thought that data race is just race condition. But apparently, race conditions it's a more general term. It's sort of an umbrella term that includes multiple different types. And yeah, it turns out data race is a kind of race condition. Good to know. Good to know. Like data race could be one thread writes hello and the other writes world, and you end up with hurled. Oh, so like overwriting, not, well, yeah, okay, okay. Oh, the data gets mixed. I didn't even think about that. I didn't think about that. Though that, yeah, that, yeah, I didn't think about that because the way I was looking at it, I was like, okay, at a time, even if both of those threads are running, at a time, only one thread can write to that location, right? Um, at least that's what I was assuming. But apparently that's not the case because it seems like two things could try and write to this, and then you end up with actual like garbage data because this isn't even like proper data that has been written and it's being read later. So yeah, this is a different thing than what I was imagining. Though what I was imagining was similar, except I didn't think it was possible for them both to write to the same location at the exact same time, and instead of one writing over the other, their data just gets their data just gets mangled. No, then it isn't data race. So I had a wrong understanding of what data race is. And even when I read this, um, I think even here I didn't understand that that's what could happen. I don't know if they mentioned that. Yeah, it does mention that such as a memory location holding an arbitrary combination of bits from different writes, also called a torn write. And this can also lead to program crashes, which, yes, that makes sense. Programming languages generally define this as undefined behavior to allow compilers and processors to perform aggressive optimization. If only one thread can write, you use synchronization primitives. Interesting. Good to know. Hell yeah. Hell yeah. Good to know. Damn, I've learned a bunch here. Thanks for the information. Hell yeah. And I'm gonna be looking into this microcontroller as well. What's the performance of this like? So um specs. Okay, 16 KB flash, 2 KB SRAM, 18 IO ports, operating at 3.3 slash 5V. The chip itself also operates at 5V, or is the 5V through like a dev board, kind of like how the ESP32 works? Okay, then it supports one wire debug, a 10-bit ADC, a 10-bit ADC, timers, and then UART, I2C, SPI, so and so, so and so. It is ideal for cost-effective applications. Okay, the processor is King Key. Okay, King K. Uh, oh, I can do the comparison like this versus ESP32. Okay, it's an ultra low cost 32-bit RISC-V microcontroller, ideal for replacing 8-bit chips in simple tasks. The ESP32 is a significantly more powerful, high cost IoT platform for IoT platform with Wi-Fi slash Bluetooth. The CH so and so is best for simple, cheap, power conscious applications, while the ESP32 suits complex connected projects. Okay, okay, good to know. Good to know. I was also looking for like, okay, so the CPU also, there's a difference between the two aside from just the architecture. The CPU is single core, 48 megahertz on the CH32. Um, on the ESP32, it's anywhere between 160 to 240 megahertz, and it's a dual core processor or dual core CPU. And you can get it in Extensa or RISC-V architecture. That being said, again, solely because of how cheap these microcontrollers are, I'm very much interested in trying them out because these would be incredible for hacking different types of applications, different types of electronics, because of how cheap they are. If there's like, for example, okay, I'm getting into robotics, right? Oh wait, I missed some messages. If you're interested in that stuff, look up sequential consistency, read buffers, store buffers, invalidate queues, total store order, partial store order, relaxed memory order, happened before relation, and so on. I can hold on, I can note this down. Let's um, research. Okay, wait, I need to be able to look at this. Oh, wait, I have my, wait, I'm gonna, okay, I'll do it from here. Uh, sequential, se can I just copy this? I can just copy this. You know what? I'll just copy this. Yeah, I'll just copy this. Yeah, thanks for the information. I'll probably look all of these things up. Not soon, but whenever I do get into multi-threading, specifically like bare bones multi-threading, and as I'm exploring Tokyo further because I didn't get a chance to finish learning Tokyo, I explored like a tiny bit of it, just enough to spawn tasks for single single async sort of not single but like one-off async operations, and multi-threaded operations as well. But like I didn't go deep enough into it to where threads can communicate with each other. Threads can like operate on the same data and stuff like that. I was in one such chapter where we looked into mutex, and I think the other one was arc mutex. But I didn't like go too deep into that. So I mean, it's good to have these things for researching. Okay, it isn't the most performant thing ever, but if you only work with like sensors and stuff, you don't have high performance requirements and stuff, you don't have high performance requirements. Most of the time, yes. Wait, I forgot what that was for. Oh, I think this was for when I was talking about like um, it could be used for situations where you don't like the CH32 could be used for situations where you don't need like the most you don't need a whole lot of processing. That's the word I was looking for. You don't need a whole lot of processing to be done. But this is great. Um, Okay, also cache consistency is probably an important one to add to that list. I'd start with that. They are what atomics are based on. And primitives are wait-free and lock-free algorithms and general synchronization primitives. Good to know. Definitely good to know. I'm I'm trying to think about like the various applications with CH32 because okay, let's compare ESP32 with the thing that I found just now, like specifically because okay, this thing that I found, like I found CH32 on AliExpress, specifically CH32 V. I'm just gonna say V3. Link E kit. That's what I found specifically. Without being on offer, this thing is already cheap. So if I'm able to um, get like a pack of, I don't know, two or three, maybe it might be cheaper. And because this without offer it's already cheap, I might actually be able to get something on offer that is much cheaper. Before I rush to buy this though, I would like to do research on the Rust tool chain for this. Actually, hold on. If the CH32 HAL is based on embedded HAL, the API is not supposed to be all that different, unless I'm mistaken. I mean, of course, um, if it's something CH32 specific, then yeah, it's going to be a little different. But in terms of it being embedded HAL related, I don't think the API should be that different. Take a look at CN Lore's YouTube channel. He has done some very Yo, okay. Okay. I remember meeting CN Lore in VR chat through another group, and they've done some amazing stuff. Like at the time, I didn't know that they did a bunch of this. I'd found out about them through I'd found out about CN Lore through there was a project that somebody had made in VR chat called Audio Link. Yes, and CN Lore had contributed to that pretty heavily, I believe. And then I went and looked at CN Lore's GitHub, and I saw a whole bunch of like projects there, a whole lot of like related stuff. Then I went to their YouTube channel and I saw like a whole bunch of like very interesting videos and lots of great projects and stuff through CN Lore. That's where. So initially, when you had mentioned this microcontroller, I couldn't point out where exactly I had heard of this microcontroller, but I think it was on CN Lore's channel or maybe their Twitter or somewhere that I had heard about this, or maybe it was GitHub, because CN Lore's community contributed towards working on a library to do something with this microcontroller. Yeah, yeah, I remember. I don't remember what the library was. CN Lore's community helped with working on some sort of functionality, some sort of library for this microcontroller. I remember seeing one other video. I believe that was also CN Lore's video. Um, at the time, I was looking for cheap e-ink displays, e-paper displays, and there was one video that CN Lore did making like I think it was a gift for his mom, maybe for like a birthday kind of thing, where he made like this little. Um, it wasn't actually little, no, it was like palm sized maybe. The e-ink display itself. Um, they'd made a sort of what do you call it? Like those digital photo frames. But the great thing about that was it didn't drink too much battery power. It was pretty low powered while also being able to display stuff. But yeah, yeah. Now that you mentioned CN Lore's name, and also the fact that you mentioned that he's done some crazy shit with CH32. I believe that was the first time that I'd I'd found out about this chip. I never looked further into it because I was already doing research on ESP32. Let me compare the price with ESP32 because I am gonna be getting into robotics once I'm more comfortable uh, with like basic microcontroller stuff. So later on, I'm gonna need cheap microcontrollers that can that can control different parts of the of whatever I'm building. And so having these kinds of microcontrollers at hand would be very, very useful. Because, yeah, e-paper doesn't drain power when not changing pixels. I, I wanted to get, okay, so my issue was, so CNLore got the e-paper from a specific person or a specific seller. When I looked for e-paper, I wasn't able to find good cheap stuff. A bunch of the stuff that I was finding, it was around the same price as the TFT displays. My thing wasn't that I was trying to just get. Um, my thing wasn't that I was just trying to get. What? Hold on. There were two things. There were two things here. Hold on. I'm losing my train of thought. My thing wasn't just that I was trying to get something that doesn't. There you go. I've got it back. Um, I wasn't just trying to get something that uses less power. Less power was definitely one of the objectives, one of the requirements. The next thing was that it was supposed to be cheap. And when I looked at the price difference between the e-paper display, at least the one that I found, because you have the display itself, and the display is usually connected to a module. The module is what's controlling it, right? Um, I would have to buy the entire thing, and usually the price would come to around the same price as a TFT display, like an ILI 9341 display's price. And at that point, I was like, okay, if that's the case, then I'll just go for this. Okay, ESP32 doesn't really go below $1. CH32 is at like 10 cents. Ads BRB. Welcome back. You can't compare e-paper with LCD. They're made for very different purposes. So, okay, I get that, but I'm talking about like in my case, when I was looking into these displays, and back then I didn't really know too much about the displays. I was just looking for a display. So my first thing was, what's cheaper? What is the cheapest thing that I can find while still being able to do something, still being able to like display stuff? And even with e-paper, um, you have like different types. Not all of them are color. You do get quite a lot of like black and white ones or whatever the shade is there, whatever the grayscale shade is there. Yeah, so not black and white necessarily. It's a grayscale kind of thing because you can have like I think you can have intensity between them. Why was I talking about this? I forgot where I was going with this. I looked into TFT displays. I looked into e-paper. I think what I was trying to go for was something that lets me do RGB, but is also super cheap. Granted, the TFT displays, not cheap at all. And the bigger you go, the more expensive it becomes. Um, though, now that I've bought them, I also want, I actually have one of the older LCD displays. I want to buy a couple more of those, and I want to buy OLED displays as well. But those are all for like, because the TFT display was for a certain purpose. I wanted a certain level of quality in it. But like when I'm dealing with the LCD display and OLED and stuff, I'm not necessarily looking for quality of image. I'm looking to display information. So for the projects that I'm working on where information needs to be displayed in a certain way, um, especially with something like robotics, um, I think the other displays would be much better solely because of the price. Okay, like e-paper doesn't use any power at all when not changing what is displayed. You can literally unplug them and the pictures stay. I didn't know that. Wait, that's interesting. I didn't know that. Okay, yeah, you won't get e-paper for as cheap. And color e-paper is generally worse color accuracy than LCD. Only in the last few years, color e-paper displays really became a thing. Your MHO934. What is that? Hold on. Oh, it's an oscilloscope. Nice. Hell yeah. Good for you. Good for you. Awesome. I might look into buying an oscilloscope much later on once I actually know what I'm doing when it comes to digital and to a certain extent analog electronics as well. I might look into getting an oscilloscope. Though, holy shit, this is $1,000? Damn. Okay, that's crazy. That's wild. Though, I mean, you probably like because of the amount of knowledge you have in this, and probably the much more complex projects you're doing, you actually have use for this kind of a thing. I've been interested in oscilloscopes in the past, but like once I looked into the once I looked into the price of a proper oscilloscope, because I could go for a cheap one, but then I feel like with something like an oscilloscope, you probably want to put a little bit of money into it to get something good quality. That being said, yeah, either way, whether it's cheap or a good quality one, I'm probably gonna get one at a later time. Yeah, but good for you. Good for you. You can firmware hack the MHO934 from a 350 megahertz front end to a MHO98 with a 1 gigahertz front end. Interesting. Hell yeah. Wait, so does the front end basically help you with a much more a much better frame rate aside from the frame rate, like I mean obviously that's going to help in various ways as well, but like aside from that, what more are you, because I don't know anything about oscilloscopes, so be it the front end or the back end, but like what more are you, oh, accidentally hit a key, what more are you able to do through through the hack? I would be interested in finding out. Okay, I was supposed to be looking at ESP32 just to compare the price. Okay, yeah. So, um, so for me, I'm not going just for the chip. Whether I go for an ESP32 or a CH32, I'm definitely not going just for the chip. I'm going to be going for the dev board every single time. Um, and so keeping that in mind, the prices that I'm seeing here, how do I, okay, I'm seeing similar prices, and that's without discount. That is without discount. I'm seeing similar prices between the ESP32. You know, I think this might be the difference between just an ESP32 or something like an ESP32, let's say S3. Let me look that up. I need to see something that's not on. Oh, yeah, there it is. Okay. So an S3 itself would be much more expensive, but then the ESP32 itself um, is pretty cheap. I'm trying to, because like I'm trying to decide if I want to put time into looking into the CH32 as well or not. And a major determining factor for me is the price, because if the prices are similar between the ESP32 and the CH32, I might as well just stick with the ESP32. If I'm able to find, okay, let me try looking up CH32 V3003, because the specific one that I found, it's cheap, but not all that cheaper, if that makes sense. Um, oh, okay, this is good. This is cheap. This this thing that I'm looking at, what's the dev board for it called? Because there's something from a company called 10 Star, 10 Star Robot. Um, let's say development board. Give me a second here. Okay, like an oscilloscope does have an ADC that mainly has specs of one, sample rate, meaning how many times per second it can, capture a voltage level, and two, bit count or resolution, which is how accurate they are. Per Nyquist, you generally need 2x higher sample rate to capture a signal of a certain speed at minimum, theoretically. But you really want a 3x or 4x higher sample rate than the signal you want to capture. The front end, the front end is then the analog signal processing, processing the signal you are capturing. The front end is then, oh, okay, okay. The front end is then the analog signal processing the signal you are capturing. What? The front end is then the analog. The front end is then processing the analog signal you're capturing. It goes through before it goes to the ADC. The sample rate and bandwidth basically limits how fast the signals are you can capture. Compare them on so and so. Interesting. Interesting. I've kind of understood it. I haven't fully understood because I don't know too much about oscilloscopes, but I'm kind of able to make sense, at least with the top part of the first half of the message. Kind of able to make sense out of it. Now, I'm looking at these, and no, they might actually be cheaper. I'm looking at the CH32, and yeah, yeah, they are cheaper. Because like what I'm seeing here for the price of, let's say, because like both of these are on 50% discount. I'm trying to look for something that isn't on discount so I can like get a proper. And yeah, I'm seeing that here as well. Like one of these would be around half the price. Yeah, around half or two-thirds of the price. I want to say one third, but that might be a stretch. around half or two-thirds the price of the of an ESP32. And if that's the case, I give me a second here. Okay. LCSC for the chips, not oscilloscopes. CH32 should be cheaper. Yeah, I was that's what I was trying to find. I was trying to get the search to show me that yes, it is cheaper, and it turns out yes, it is actually cheaper, if not much more cheaper. Like at the very least, it's a little bit cheaper. But no, I think it's that's what I was talking about. Like either half the price. So yeah, either half the price or maybe two-thirds of the price of an ESP32. And I feel like if that is the case, then I might look into this because aside from just robotics, there are a bunch of other like applications. There are a bunch of other even like tiny projects that I wanted to work on, uh, or even if it's like hacking some sort of electronics, some sort of like general purpose electronics. I feel like I would be able to. Um, I feel like I would be able to do a lot of that stuff, or a lot more of those projects if I had a lot more of these microcontrollers just laying around. I mean, at this point, I have a bunch of ESP32s laying around and I'm going to be using them. But then I do want cheaper ones as well. And now I've got this. I can get 10 dev boards for 640 euros. I've been comparing the prices on AliExpress, specifically only on AliExpress because I buy all my electronics, all my hobby electronics stuff from here. And no, yeah, you're right. It is definitely more cheaper than the ESP32. If that is the case, I could place another order. There were a couple of things that I might have wanted to buy that I was kind of putting off. Maybe I'll look into like two or three other modules that I want to buy, or maybe I'll just stick to this one thing because this is going to take like a minimum of 1 week, if not 2 weeks, to arrive. I can place this one order. This is nice and cheap. And first I'm going to look into the. Oh, you know what I could do? Because this is so cheap, I could place an order for. No, okay. I haven't factored in shipping, so I need to see. Oh, AliExpress. AliExpress does have this choice thing where you can choose three products, three items, and then you get like free shipping. So then I guess that would make it cheaper. I really recommend getting a JTAG and USB serial adapter. You just need one of them, and then you're pretty good for a long time. You know what? I might look into that. I might look into. First, I'm going to do some research on um, a JTAG and USB. Well, a JTAG adapter and a USB serial adapter. I need to first understand what each of these things are and uh, how they work and what I would be using them for. Then I'll look into the price and see how cheap or expensive they might be. Let me look that up. JTAG, I think it's JTAG USB serial adapter. JTAG USB. I like that I'm looking up JTAG and in the search results, or I looked up JTAG USB and it's showing JTAG USB blaster. JTAG USB serial adapter. It is showing JTAG debugger. There's also JTAG programmer. What currency are you comparing in? My currency is the Bahraini dinar, BD, and mine is being displayed in BD as well. But even if I looked at it in dollars, that also that would work. Oh, okay. So I'm looking at the price for these adapters. Wait, this is for a debugger. Let's look up exactly what. So USB. Let's look up serial USB adapter or USB serial adapter. Oh yeah, yeah. No, I'm not. I'm not looking it up on the machine that I'm streaming from. This specific thing, I'm looking it up on another machine. Search for something like FT232H, a debugger, programmer, whatever you want to call it. Okay, so they're the same thing. Okay, because like the search was showing it in different terms. I'm assuming because different people use different terms for the thing. Oh, okay. The one that you mentioned is actually cheap. This says USB to serial adapter. And okay, I need this for I need this for Probe RS or for something else. Like what would I be using this for? Because I haven't gotten to the debugging side of, hold on. Yeah, I haven't gotten to the debugging side of what do you call it? Microcontrollers yet. So, oh, actually, wait. So we looked up USB. Let's look up JTAG. JTAG, is JTAG serial adapter a thing? Actually, okay, ESPROG is also showing up here. There's a cheap one, and then there's one that is quite literally 10 times as expensive. And the 10 times as expensive one is the one that had popped up initially, and the majority of them are actually 10 times as expensive. Now, I'm not going to touch this one right now. We'll go for the previous one that you had showed, that you had talked about, the FT232. You said H. I think these are like different. Okay, multifunction high speed USB to JTAG UART FIFO SPI I2C module is what the name is for me. ProBars, for example, but also just generally programming microcontrollers. FT232H. Make sure the cheap one is not just an adapter. Okay, that's good to keep in mind. So I guess that's something I have to watch out for. F3232H, because I wouldn't have thought about this thing. Like, okay, um, wait, make sure the cheap one isn't just an adapter. So what I'm looking for is, because like earlier I was looking for a USB serial adapter. I'm guessing that's why it was so cheap. So I'm looking at FT232 and um right, so it's not expensive, but I think I'll hold off on this until I actually do all my research on this and understand what this is, what it does, and why I'm buying it. I think for now for now, I'll do all my research on it, and once I actually have the need for it, once I'm doing projects where I need to do debugging for this kind of stuff, then I'll actually look into it. Oh, you were saying for the ESP prog, make sure it's not just an adapter. You know what? Okay, this is funny. I think okay, when I looked at ESP prog, I mentioned that one I'd found was incredibly cheap and the other one was 10 times as expensive. I think the incredibly cheap one might have just been the adapter. It might have just been the adapter and not the actual like thing that I need. So the actual thing was pricey. That's why it was 10 times as expensive. But it's good to know, it's good to have something to actually look at, like this thing that you mentioned, the FT232H. So thanks for the information. Now I have something to do research on and look into for future projects. Hopefully, once I start doing more complex microcontroller stuff, I'll be using this. Okay, no, a bunch of ESP listings I saw just had an adapter from the pin out for a specific ESP board to a programmer, which you don't really need. Okay, okay. I'm probably not going to be going anywhere near ESP because of the price. At least not for now. For now, I want to go for the cheaper one, and this FT232H that you mentioned is cheaper. There was another one that was popping up. There were two or three others actually. So if I just look up FT232, they have FT232RL and then just FT232. Then there was also, I think, FT232L as well, maybe. I don't remember. But yeah, they have RL as well. And that seems to be really cheap. Any idea what's the difference between these two? Because you mentioned H, and then there's RL. Because one is cheaper than the other, this has me wondering about the capabilities of them and what each of them would be used for. I think both of them might be used for the same thing, but then one of them might have more functionality than the other. I just don't know what the more functionality, quote unquote, is. Also, there's something else popping up here as well. CP2102 micro. Let me look up what this is. Micro. It's a USB to UART bridge. Okay, I don't need that because the ESP32 does have one already. Wait, does the because the CH32 is going to be connected via USB. If I'm trying to use, for example, the serial monitor, USB to UART has to be involved. So does the dev board already contain the USB to UART bridge? Development board, um, USB to UART. Okay, RL is only USB serial and not JTAG, I think. H can do both. Right, so I'm going to need to look into um, both USB serial and JTAG. JTAG, from what I remember, is for debugging. I've seen a bunch of other people use it when they're trying to hack the device. Rather, not hack, but more reverse engineer it. Try to uh, understand how the device is working. I think somebody had used it to dump the ROM of a device as well. I don't remember. This was a while back. Somebody was doing a somebody was doing a they were they were trying to dump the ROM of one of those crypto wallets that somebody had made. So they'd gotten their hands on the wallet, and they were trying to dump the ROM for that. Not just the ROM, the entire memory, in fact, while the thing is running. Yes, but you can also flash firmware and so on using it. Interesting. So, okay, I feel like these kinds of tools would be very useful if I'm not using something like a development board, if I'm using something even more lower level than that. Yeah, I feel like these kinds of tools become, and especially since you mentioned this thing about flashing the firmware, I feel like these kinds of tools become much more useful for those kinds of purposes, when you're not using an entire development board, which does make me curious about how the development board enables you. Well, it could be a mixture of the development board and the module that's on it, how it enables you to flash the firmware on there. Yep, JTAG can do all that, even with a dev board. Oh, you know what? Yeah, I've always been curious about this thing about like dumping the ROM off of an hold on, dumping the ROM from any sort of electronics that's using a ROM to try and understand what's going on in there. Maybe once I get one of these things, I might be able to do that much more easily. Though, to be fair, what I'm going to be trying to reverse engineer slash hack is mostly going to be cheap electronics. So my first challenge there is going to be getting something where the functionality isn't under some kind of um, epoxy resin blob. Most of them don't have JTAG on the USB port, but only serial. Well, let me explain. Okay, in the meantime, so aside from the USB, aside from this serial adapter, I'm I'm definitely interested in CH32. Again, solely because of the price. It's solely because this thing is so damn cheap, and I'm always looking for cheaper microcontrollers because there are so many different applications that I would be able to, like, wait a minute, does the CH32 even involve any sort of like RF tech? Anything like Wi-Fi or Bluetooth or something? I didn't look into that. CH so and so so and so. Wait, let me look up specs because I think it does. Maybe I'm not sure. Wait. Okay, it doesn't mention any of those. It mentions the wired connections. There's something called USR, which I've never heard of. So that's that's something I can look into. Then there's I2C, SPI, and others. Yeah, I don't think this has Wi-Fi or Bluetooth. Okay, okay, good to know. It's good to keep these things in mind. I mean, it's not like every single project that I'm building is going to be using Wi-Fi and Bluetooth. Rarely any of the projects that I'm building are going to be using it. But like, I need to know the comparison. Yeah, it says the ESP32 is a powerful, more expensive SoC with Wi-Fi, Bluetooth, dual cores, and significantly higher memory for IoT and complex applications. Yes, okay, okay. All right. Okay, the dev boards usually work by having a so-called bootloader on the actual chip that runs before your code and can listen to USB serial commands to overwrite the firmware on the chip. JTAG instead is an actual hardware interface that can directly interface with the chip even without any firmware on the chip itself. No, the so-and-so doesn't have a dumb UC. What? No, the so-and-so is just a dumb UC. What's a UC? Hold on. Um, if you need Wi-Fi, you should go with the ESP. Yeah, yeah, okay. Um, I guess that makes sense, right? Because like IoT, Internet of Things device, and yeah, I won't need Wi-Fi or even Bluetooth for the majority of the applications that I'm working with. And if it's something complex that requires, like let's say it's a robot that has many moving parts, for the sake of having Wi-Fi, I can have one ESP32 and then multiple smaller CH32s. Um, hold on. A dumb. Oh, UC as in microcontroller. Okay, UC as in microcontroller. Oh, you just said that as well. UC is short for microcontroller. I did not know that. I've actually never used that term. Um, since JTAG is a hardware interface, you can do stuff like halting execution, inspecting the memory and registers at that point, stepping through one instruction at a time. Good to know. Good to know. It's okay. It's also interesting that you can halt the execution, which obviously, yeah, I mean, if you're debugging like one step at a time, you have to do that. But it's interesting that you can halt the execution of the hardware, the other hardware. I mean, at least to me, it's interesting because I've never looked into hardware debugging. So I guess this will be a good learning experience for me. Whenever I do like get into it, it'll be a good learning experience for me. For now, though, I'm excited for this thing, the CH32, and I'm gonna look into its into um, the Rust tools that are available for it. I'm gonna look into, how do I say this, the CH32 Rust ecosystem. That's what I'm. Yeah, that's what I was trying to say. I'm gonna look into that, and I'm hoping that it is not only mature, but also an active community, and that I'm able to, find a bunch of information on it. Let me look this up. Um, Rust book. Okay, CH32RS GitHub organization. Like you can basically use LLDB/GDB on your UC directly. Yeah, yeah, pretty much. Because like that's what was kind of like that's what was. So I've never used LLDB, but I've used GDB. Um, and like how you're able to, and just in general, like how debugging works, like even without GDB, generally you are able to step through the program, you are able to halt the execution. The fact that you're able to halt the execution another hardware. That's kind of like, that's really interesting to me. Okay, so there is an organization for this. They have a bunch of like repos and stuff. Embedded Rust device crates for WCH's RISC-V and Cortex-M microcontrollers. W-Link, CH-HAL. Okay, let's open this up. Is there like a book or something that's... This project is not affiliated with WCH. This is a hobby project. Also, the repo hasn't been updated in years. I'm gonna have to... oh, never mind. The the HAL was updated last week. Okay, okay. Let's look into that. Look at github.com/c. Yeah, yeah. That's the one that I just found. Because I looked at CH32RS slash CH32RS. That one hasn't been updated for a while. Um, but that's also not a Rust-based thing. That's a Python-based thing. So what I'm looking for is the HAL, and I'm guessing this is based on embedded HAL, because if it is, oh, it's this HAL creates is the Embassy framework driver for WCH's 32-bit RISC-V microcontrollers. This HAL creates uses the Metapack approach to support multiple chips on the same crate. The Metapack is maintained in so and so. This project is under development. While it's usable for experimentation and testing, it may not be fully stable for production environments. All right, good to know. Good to know. Okay, so what all is supported here? Oh, so here they're showing different families of this microcontroller. So they have V2, V3, which I'm assuming CH32V003 might be V3, unless I'm mistaken, because there's a V1, V0, X0, L1, and then there's higher ones as well. CH641, CH643. It's based on embedded HAL? Hell yeah. Okay. So my assumption there, because it's based on embedded HAL, is that the API is hopefully not going to be all that different. And so whatever I'm learning on the ESP32 side, because I mean, definitely there's going to be some bit of difference, because, one is ESP32, the other is CH32. There's going to be some difference. I'm hoping there's not going to be that big of an API difference. Um, but now that I'm thinking about it, I mean, the two the two crates are being they can be made with different designs, so there could still be like a difference. Hold on, let's take a look at a very simple. They most probably have an example section. Yeah, they do. Okay. um Hold up. Okay. Oh, dude, I was mistaken. No, V003 is V0. I was wrong. Earlier I was mentioning that they have V2 and V3, and I thought V003 was V3. But looking at these examples, they're mentioning V003 and then V103, then V203, and then V303 or 305. Sorry. Wait, no, you're saying something else here, Justice. You're saying V003 is V3. So then what is V305? Which one did I get wrong? Exactly, because okay, wait. So let me transition back um, here. And just real quick, temporarily, let me, wrong one. I was going for this. And yeah, let me just temporarily increase the size of this and bring it here. Yeah. So this is what I'm currently looking at, and I can bring it like this. Later on, I'll change the size and take it back to the bottom left because I usually don't have this thing that big because most of the time the what I'm trying to show is the other work that I'm doing, not what's on the browser. For now, though, what needs to be shown is what's on the browser. Actually, I might be mistaken, not sure. It might be V0. I'm confused about this as well. I'm not sure which one is which. So I guess that's something worth doing research on. Maybe Gemini knows about this, so I can ask Gemini. Um, hold on. I hit Control Shift 0 too early. But okay, here, yeah, here's the table that they're showing. And I saw V2 and V3. Then there's V1, V0. So a bunch of this other stuff at the moment, what I'm doing, um, at the moment, given my very limited microcontroller knowledge, I doubt I'm even going to be using any of this. I don't know, some of it might be debugging related as well. I doubt I'm going to be using any of it. OTG, possibly, maybe I might use at some point, but even that, it's a huge maybe. So I don't think I should be looking into any of those. All of the other stuff is supported pretty much. So then I guess let me look into V3, V307, development board. Okay, you might be right. Go to that linked CH32 data repo for a full list of, okay. They all support SWD, which is basically a JTAG derivative for debugging, as far as I know. Okay. All right. The structured MCU DB for WCH MCUs. Okay. CH32 data is a project that aims to provide structured machine readable data for WCH's 32-bit microcontrollers. This project is so and so, so and so, so and so. Okay. Data sources, families. Okay, there it is. So V0 is low price, V1. But what's interesting here is it says V2A and V2C in brackets. Okay, CH32L1 is low power. Okay. Wait, this says RGB driver. Is this solely an RGB driver? CH643. Is that what it said? 643. Yeah. Is an RGB display driver microcontroller based on RISC-V, built-in 3 16-channel PWM current drive. Okay, yeah, this is specifically meant for that purpose. Okay, that is the core. You see that below. Oh, V2A and V2C is the this. Okay, okay. Thank you for the information. Hell yeah, hell yeah. Um, cores. So this is specifying what type of core it uses, what type of these are using so and so IP core. Okay, right. So I'm guessing what we are talking about, what we've been talking about all this time, is CH32V0. For the sake of just confirming it, I'm gonna look at the price of CH32. Oh wait, this thing loaded up. CH32 V307 is absolutely not cheap. The board is also kind of beefy, if that makes sense. It's got a lot of stuff going on. It's also got like multiple. It's got like multiple USB Type C ports and one other port, which is one of those older like USB. I don't remember one of the older USB ports. It's like the old one that you could find on the Arduino, on Arduino Uno. But yeah, it is not cheap at all. So we're gonna go for CH32V, let's say 103, because we are looking at 003, right? And then let's do 103 development board. Yep, that is also more expensive than the 003. So we are looking at V0. Yeah, yeah, that's cool. So the whole idea, at least for me, the whole idea was to get something cheaper. Um, okay, out of curiosity, because I've never looked into STM microcontrollers. So out of curiosity, how different would the STM32 microcontroller? Let me look this up. STM32 versus ESP32 versus CH32. I like that they're all 32, which makes sense because 32 bits. So yeah. Um, let me let me narrow it down. Okay. The search is okay. Uh, the CH32 V307 are around the same price as the ESP32 if you look at the chip prices. If you want to look at chip prices, I would recommend looking at lcsc.com. So the thing is, I want to look at the like directly. I don't want to just look at the chip price. I want to look at the dev board price. And I mean, at that point, I'm better off just looking at the e-commerce website specifically, which I mean, in this case, AliExpress. I'm better off looking it up at AliExpress because I'm going to be buying it from there directly. STM32 is more on the price level of ESP32 as far as I know. Okay, so choosing between these three depends on. So I tried asking Gemini. Choosing between these three depends entirely on whether you value industrial reliability, which is the STM32, wireless connectivity, which is ESP32, or extreme cost cutting, which is CH32. Um, As of 2026, the landscape has shifted. STM32 has localized much of its production to stay competitive. ESP32 has fully embraced the RISC-V architecture for its newer chips, and CH32 has moved from being a quote-unquote clone to a legitimate ultra-budget powerhouse. Okay, all right. There's a lot more written here. Um, I'm gonna read this off stream, not right now. You'll design your own PCBs at some point in time. Trust me. You know what? You might be right. You might be right because um, there's only so far that you can go in terms of using microcontroller dev boards with a bunch of modules for various types of functionality. Like I have a whole bunch of different types of modules for various things. Just some examples. I was showing earlier in the stream. I was sure I'm not going to be using this practically for any of my serious projects. I mean, maybe I might, you never know. But like for the sake of learning, I bought this. Actually, wait, is the webcam visible on stream? Um, Hold on. Let Yeah. Here's the. So I bought one of these things. This is an RFID module. I bought this for, well, learning about RFID, right? But I've heard from a bunch of other, like, much more experienced people who are, well, much more experienced in electronic stuff that at when you're designing like a more serious product, or if it's something more complex, like not necessarily for selling, but like when you're designing something that involves a bunch of other pieces, then you there's only so far that you can go in terms of using a bunch of modules, because the entire setup is going to become very clunky, if that makes sense. Well, the PCBs cost is a bit, well, the PCBs cost a bit as well, but still. So, okay, I haven't touched PCBs so far. Um, More specifically, like designing PCBs. I haven't touched that thing so far at all. I think at some point be uh, I might be getting into it when the need arises. When I need to get into it, then I will. For the time being, I'm mainly working with perf boards and these the project cases. The What do you call them? The plastic. What are they called? There was a specific like plastic standard that I can't remember. Wait, um, project box plastic standard. There was a What was it? APB, ABS plastic. Yeah, I have a couple of those. I have a couple of those boxes. I have a couple of perf boards. I have a bunch of these modules and headers and stuff. Um, I think quite a few of the projects that I'm going to do initially, uh, they're going to be with all of those things, and they are not going to be small in the slightest bit. Specifically because of the fact that the microcontroller is a separate development board, the PCB is its own thing on which I'm trying to fit the microcontroller. Then there's going to be each of the each of the modules. They're going to be their own PCBs, which I'm also trying to fit onto the perf board. So the entire setup is going to look very. It's gonna be a little bit of a beefy setup. And yeah, you're right. At some point, I might need to get into. PCBs. I'm trying to avoid that for now though, because first of all, you mentioned it, the PCB thing, the cost for PCB. There's also the the cost of printing the PCB. It's less about the PCB itself and more about printing the PCB, because I can learn to use KiCad's tools to design the PCB or whatever other thing I need to use. I think I can use that to design the PCB, but then the actual printing, I don't think I can do that by myself, unless I order, certain tools. Um, so I think that at that point it's gonna start to cost more money. Go to jlcpcb.com. Probably cheaper to order your own PCBs than you expect. Is it? I might look into that. What is it? JLC PCB. Yeah, I might look into this. Um, it says instant online PCB quote. Get PCBs for only $2. Hey, you know what? Okay, okay. I might look into this later on when I do get into. I'd order the PCBs directly at some PCB manufacturer rather than manufacturing them myself. I remember because I remember seeing these videos of um, people talking about like how you can, you know, build your own PCB printing setup at home, and I was like, man, with my electronics workbench, I already have enough of a mess going on. I don't think I want to get into trying to build the thing, trying to print the PCBs at home. It's not even going to be printing. The setup that they were showing was a different kind of thing. It wasn't it wasn't necessarily good because like when I'm designing, if I'm going to be designing the PCB, it's going to be in some kind of software, right? And then I'll have to export that, and then that has to then be printed by something. And there's no way I'm going to get enough money for getting one of those PCB printing things. I might as well, like you said, get it manufactured from someone. Um, but you know what? This is this is not bad for $2. If I'm like I can prototype the entire thing, and then for $2 I can have this thing printed. This could be useful for me. Yeah, I'm not doing that either. I just order them to be made for me. This would be good to keep in mind once I get into PCBs. Okay, okay. Now, uh, yeah, yeah. Okay. You know what? We made some good progress today in terms of learning. Yo, I mean, Justice, you shared some like a lot of good information. So thanks for the information. Also, thanks for hanging out and chatting and stuff. I appreciate it. Um, hold on. Zaynar, also, thank you very much for stopping by and hanging out and chatting. I appreciate it. Anyone else who might have been lurking in the chat, thanks for hanging out. We've made some good progress today. We're going to continue learning about ESP32 Rust programming tomorrow from this amazing book. Again, if you guys haven't checked this out, go check it out. It's esp32.implerust.com. It takes you from the beginning, which is like teaching you about the basics of ESP32 microcontrollers, and also to a certain extent microcontrollers in general. It takes you from those basics going all the way to, you know, how to program them and how to use their various systems, their various like components like the ADC and PWM and various like serial communication protocols and all of that stuff. It explains those protocols as well. It explains how all of that stuff works. So this book is amazing, and we're going to be going through this for the coming days because this is how I'm going to be getting into making my various ESP32 projects. As I said, it's probably not as expensive as you were expecting. I might have been wrong about that. You know what? Yeah, I might have been wrong about that because I was expecting it to be like much more expensive than just this, but it seems like somebody, probably multiple people at this point, they've managed to get the costs down. And like my what I was thinking about was it was probably going to be like I would probably have to try and find um, manufacturers in China, and they probably have systems set up where you can order wholesale PCBs or even like a few PCBs for really cheap. So what I was expecting was that I was gonna have to find an AliExpress for PCBs, for designing and or well for ordering PCBs, where you can give them your design and they'll print the thing out. But yeah, okay, okay. Thank you for letting me know about this one as well. Now that being said, that's going to be it for today's stream. I'm probably not going to be rating anyone. I'm just going to continue with all of this research, and yeah, we're going to stream again tomorrow. So guys, thanks a lot for hanging out. I appreciate it. I hope you guys have a nice day, and I'll see you all next time. Peace.